Okay, everybody, we're going to get started. Can I hear that? Okay. Welcome back on a Monday morning at 9 o'clock in the morning to your first class of this S term to Software and Design and Communication. I am Professor Alan Chong. This is Professor Abed Yassin, and we'll be taking you through this course this year. Okay. I'll start with a reminder that this is an active learning classroom. I'm assuming you guys are familiar with the microphones and how they work and how to turn them on and turn them off. If you're not, it's just the front of that microphone. If you've made a mistake, just hold on to that to take to signal that you're not actually interested in speaking. And I'm going to let Professor Yassin start talking about this course right now.
Yeah. Thank you, Professor Chong. Welcome, everyone. I hope you had a good break and you are looking to ECE297 as much as Professor Chong and I. Design and communication are both important, so I can't really emphasize how important to attend this course this semester.
Professor Yassin, we've talked about this, right? It's really important that you take some strategies or take some effort into communicating a little bit better. This is a software and design and communication course after all. I'm sure you guys have seen really good speakers in your courses and in MY 150. Can somebody give some tips to Professor Yassin about how to communicate more effectively to your class, to command your class? Anybody want to give suggestions? A07.
Yep.
You'll have to speak into your mic. Oh, you're going to have to yell.
Project your voice.
Okay, so project your voice, okay? A little bit more projection, Professor Yassin. I think that's really clear. I think you were speaking down into the mic. Okay, so that's one thing. Other thoughts, guys? Somebody press your mic. Oh, D05, you have mic.
D05.
Making eye contact.
Making eye contact, right? We like to make eye contact to engage the audience, and we're going to talk a little bit more about that in the context of this course and the presentations you're going to give for this course. One more thought. What could Professor Yassin do a little bit better in order to command this room and engage your audience, you as an audience? One more thought.
No?
Well, it's good that you had at least a few ideas about how to do this, because this course is going to be a lot about software design, and Professor Yassin will talk about the project shortly, but it will also be a lot about communication, okay, and strategies for effective communication and how to create an atmosphere where your audience is listening to you, engaged, and interested in what you're talking about and can take away something from your talk, okay? And part of the reason why we started out in this way was we wanted to kind of introduce a key concept for the course very early. Okay, and we found that introductions are really key to establishing a speaker's credibility and framing an audience's understanding of a particular topic. Now, if we go to the research, okay, and there is research in engineering communication, okay, we can see repeatedly this focus on the importance of introductions. So in this piece of research from Technical Communication Quarterly, called May I Have Your Attention, right, exordial, which are introductory techniques in informative oral presentations, right? They did a bunch of research around how people received information after having an introduction, after having a bad introduction, and having no introduction at all. And their findings were pretty solid, right? They found essentially that a good introduction does three things, right? It makes audiences more likely to listen to a speech, right? Think more highly of the speaker, and also ultimately understand the speech better. So introductions are really important, right? And they also say that you make this judgment about a speaker and how, whether you want to listen to them and whether they're engaging after a very short period of time, right? Usually within a minute or so, which is why we only let Professor Yassine speak like that for about 30 seconds, right? We wanted to turn it around and make it a little bit stronger after that point, okay? So the first lesson for this course in terms of your written and in your oral communication is that introductions really matter, okay? Now the second point, the second reason why I wanted to bring up the idea of introductions, and in particular this research, okay, is to introduce you to the idea or the concept that engineering communication is not just something we teach you in APS 111, 112, okay? It's something that you're going to use throughout the course of your career, but it is also a technical field, right? It is something that is, it's not just something that is taught, it is something that is researched and studied and has its own technical journals, just like software or hardware engineering. Okay, and so there's a whole field of research that informs what we're going to teach you in the next 4 months or so, and it's an important part of your education as an engineer, okay? And it's really studied at this kind of deep level because there is so much at stake in the technical communication of information to a variety of audiences, right? Winning a research grant, successfully documenting a project, understanding the needs of your users, right, as you did in APS 111 and 112, or maintaining funding or project resources, or even selling a product that you wind up producing to consumers, okay? And there's simply just a lot of it to be done, right? If you're going to be working in computer engineering and software engineering, you're going to be involved in all of these different types of documents, right? You're going to see design documents, you're going to see use case documents, requirements documents, you're going to make design pitches, you're going to make proposals, you're going to certainly be using code comments to communicate with your group mates, and there's just a whole bunch of types and genres of materials that you're going to be working with. And this is just even outside of the everyday kind of communication you're going to be doing with your group and the kind of oral presentations you'll be doing very informally, okay? Now, there are even very important academic societies that are connected to this field, right? How many of you are familiar with IEEE? How many of you are members? Okay, so a few of you, okay, right? IEEE is a really important professional society for your, ultimately your work in industry and in academics, right? They're a professional society of computer, electrical, and electronics engineers, right? And they provide a whole bunch of training, research, conferences, and meetings, and there's a whole bunch of journals that are published by IEEE, and there's, you know, a set of standards as well. So this academic organization has about 500,000 people in it, right? It is a $1 billion company. Well, it's not a company, it's a not-for-profit. But just to give you a sense of how big it is, it runs over 2,400 conferences a year, right? Just dedicated to electrical and computer engineering, okay? Now, we should know that IEEE does have a student branch at U of T. I'm not sure if the organizers are in this class or not. Last year they were. And it's a branch of IEEE at U of T that hosts student events, like maker labs and things like that. And last year they ran Make U of T, which was a really kind of a fun event for people to participate in, okay? Now, even within IEEE, there is a sub-society that focuses on professional and engineering communication for academics, practitioners, and engineers. And they do the same sort of things, right? We provide training, research, conferences, and meetings focused primarily on the idea of professional communication, right? How you're communicating within the engineering fields, right? There is a website, right? And we have a set of experts that go out to different companies to deliver training and also to different societies and deliver workshops at their conferences. There is a academic journal that is the Transactions on Professional Communication. And then, of course, we run a conference every annual conference every year that's international. It's being held in Denmark this year on engineering communication, okay? Now, Procom also takes all of that very academic work and on their website turns that into kind of practical tips and strategies for practicing engineers, right? So what can a practicing engineer take from the research that academics are doing in this field in order to better their everyday communication? So that's something that you might want to take a look at if you have the time. There's lots of material there. Now, I am bringing this up because this is the community of practice and scholarship that my background is in, okay? And this is why I'm bringing it to you, okay? And in fact, I just rolled off as the president of IEEE Procom, and now I'm the past president. But it's an important society that can offer you a fair amount, especially as you move into industry. Okay, so a little bit more about me. I've been here for quite a long time in engineering. I've been here for about 20 years in the engineering communication program. I'm the director of that program right now. I'm also the associate director in the undergrad at ISTEP, and also the associate director of engineering science years 1 and 2. So I'm kind of all over the place in the faculty. I've been here a long time, okay? Before that, I worked primarily as a corporate trainer for communication and consulting with companies such as CGI, Autodesk, and Hatch. Okay? And as I've just said, I just came off the idea of being the president of the IEEE Professional Communication Society, okay? So I'm hoping to share my experience with you as we kind of walk you through how to communicate, not just kind of in engineering generally, but in the electrical and computer engineering discipline over the next 4 months, and I'm hoping to learn a lot from you as well, okay? And with that, I'll introduce Professor Yassine, who will tell you a little bit more about himself.
Thank you, Professor John. Can everyone hear me? Okay. Let me just switch my, yeah, thank you. Oops. Okay, so I was carefully following some of the communication skills that Professor Chong was talking about, and I'm gonna try to apply them to the rest of what I'm gonna talk today, and hopefully I'm gonna do a little bit better this time. Okay, so as Professor Chong said, I'm excited to teach this course. I think the mix of design and communication is fun to learn and teach, and I'm gonna start by briefly introducing myself and my professional career so far. Okay. So I started as a PhD student here at U of T. I graduated in 2021. My research focused in using software tools and machine learning models to improve and optimize light-activated chemotherapies. And the result of this work was an open source tool that basically the research community can use and improve upon. After I graduated, I moved to Cerebras System. It's a hardware startup that aims to accelerate AI models like ChatGPT, for example, through software and hardware. And I brought today here one of the chips that we produce to basically do that. if you remember in ECE241, your FPGAs were like these tiny chips. In Cerebrus, we produce these huge, what we call wafer scale engines to basically accelerate these AI models through fast compute and low latency. Okay. My job at Cerebrus is a compiler engineer. What we do is basically use complex algorithms in order to try to model any generic machine learning model on our wafer scale engine. So why am I telling you all of this? Well, because I really think it's helpful to understand the things that how the things that we're gonna teach in this class are applicable to the industry and your various future career paths. And I'm hoping to give you some of my experience at least, and to let you understand that. Okay. In fact, some of the algorithms that you're going to learn in this class, hopefully by the end of this course, I use them personally in my compilation at Cerebrus. And not just on the technical side, also like the non-technical side and the communication skills, the things that you're gonna learn in this class, you're probably gonna face them in any job or whatever you do after graduation. So how to work in teams, whether small or big, how to convey your findings to your superiors or like to a general audience who don't know the details of what you're working on, or how to approach a complex project like the one that you're gonna do in this course by dividing it into a set of milestones, try to work on them one by one, and so that you can eventually achieve the end goal of the project. Okay, so I hope that gave you a little bit of motivation why this course is important. Okay, so now what are the goals of this course? In this course, you work in a team of 3 to basically build a project, and it's a design project where you're gonna learn how to develop in C++ and to manage your project with you and your team members. Again, it's a team-based activity. We're going to teach you how to develop agile software projects and to improve your communication skills, as Professor Chong talked about, both oral and written, and in particular, how to make the things that you're communicating more memorable. Besides communication, we're going to teach you several software debugging, software tools that you're going to use in this project, also as well in your career after graduation. These tools are listed here. I'm not going to go over all of them. We're probably going to cover them throughout the course. But they are very important to you to learn both for this course and after that. We're going to teach you how to architect your software. What does this mean? That means like what kind of data structure that you should use in order to make your code more efficient and achieve what you want to do in a timely manner. And we're going to teach you some of the complex algorithms that are only applicable to graphics and how to basically develop things in C++ while also developing a graphical user interface for it. Okay. The basic learnings of this course are going to come out of the lectures and the tutorials. I'm going to talk about the tutorials later. Both the lectures and tutorials basically cover the principles and the key skills that you need to complete this project. Now, I know it's a 9 a.m. class on a Monday, so bear with me. I cannot force you to attend, but the project is going to be much, much more difficult if you don't. So, yeah, I hope you all attend the classes. There is a textbook for this course called Made to Stick. Professor Chong is going to talk about it in a bit. And you are required to read this course, or to read this book, sorry, or at least the first 6 chapters that cover the core principles of what you're going to teach you. And why am I telling you all this? Because there is going to be 2 presentations in this course, and at the end of each presentation, your CI or TA is going to ask you some questions, and these questions can come from the lectures, the tutorials, the book, so anything is fair game. We're not going to trick you and ask you about like detailed things, but you should know the overall picture. Okay, now we are going to teach you the basic skills that you need, but you don't learn except by doing. So what does this mean? It means that you have to take these skills that we're going to teach you and try to apply them to figure out how they work for you. you're going to, so you have to learn how to work effectively in a team in order to develop this complex application, and how to communicate effectively, whether with your team, within your team, or to your CI or TA. Now, the more effort you put in this, obviously, the more you're going to learn, and the better the outcome of the project will be. But we know that perfection is not achievable, so you have to balance your work with other courses. This also applies to anything in your future career as well. So for example, let's say you are very passionate about one project and you spend 6 months or 7 months trying to polish it while ignoring your other tasks at work. This is not going to look good at your end-of-year performance review. And let's say also that you decided to prepare the presentation 2 minutes before the deadline. That you're probably not going to do well in the presentation. So you definitely have to put effort in what you're doing, but again, try to balance whatever you're doing with your other courses. We do not want 297 to be your sole focus for this semester. Okay. As I said, we're going to teach you the key concepts, but we're not going to provide you with every answer. Why is that? Well, basically, you're not going to learn if we're going to tell you what to do every time. You have to face some challenges in order to try to overcome them and learn throughout the process. So hopefully by the end of this project, you will learn, you will have to develop the ability to learn independently, and to develop the tenacity to debug complex systems. You're definitely going to run into a lot of issues in your software, and trying to work on them one by one is going to help you learn the other stuff maybe we haven't taught you before. And you will have developed the confidence to work on an open-ended problem. Some of the milestones in this course are going to be more open-ended. We'll let it up to your creativity to decide what to do with your graphics, for example. And having this ability by the end of this course, I really believe is going to help you in your future careers. Okay. So I know Professor Chong talked about the communication aspect of this course. Now I'm going to talk about the importance of the other two aspects. Why is software important, and what do we mean by design? Where are you going to use it later? So why is software important? Well, as you probably know, software is used in everything. It's used in our TVs, in our computers. It's used in embedded systems like airplanes, medical imaging devices, for example, microwaves. It's also used in data centers that that are all over the world, and we use to basically do our web searches or like trying to translate something on the computer. It goes to the data center, it queries whatever results that you need and brings it back. It is also the building component of deep learning and artificial intelligence models that enable these machine translations or text generation, like ChatGPT. I'm pretty sure that you've used it before. Or like in driving assistance, like used in Tesla. And finally, it's also used to test and develop all kinds of designs in order to improve the products before being shipped, even if the product doesn't have a software in it. Okay, so we do this through simulation. This is, for example, a lot of simulations are used in medical imaging or MRI devices. I've used it, the picture on the right, I've used it in my PhD to do simulations in order to improve the chemotherapy. So as an engineer, you'll probably use software in some sort of way, no matter what. And finally, I wanted to mention where we use it as well in Cerebrus. It is used to automate any repetitive tasks. For example, the wafer that I'm showing you here consists of over 4 trillion transistors. That's a big number. And trying to manually design the size of each transistor is going to take probably many years. So we build software that automates this process while keeping in mind how to optimize for example, latency or the area. Now, obviously, we cannot buy such software because it's targeted to each company's hardware, so we have to write this software from scratch. Okay, so I hope this gives you a glimpse of why software is important, but the other aspect I want to talk about now is how to get better at it. Okay, and that's the only way to get better in software is through practice. I'm going to give you 30 seconds to read this quote, and does someone know who said this? Nope. Okay, does anyone know who Bill Gates is? Yeah. So Bill Gates is the co-founder of Microsoft, and he was the company leader for many years. So he's obviously a very successful businessman. But he was also an incredible software engineer, and the reason behind that is that during his high school years, he had access to the University of Washington main servers, and not many people had that opportunity at that time. So he had a lot of practice, way more practice than his peers at the time. What this quote is saying is that whatever you do, you need to practice in order to get better. And especially in software, you will keep getting better as long as you practice more and more. It doesn't max out. On the other hand, for example, a late operator, they will practice how to use the machine, for example, but then at the end they will max out because they knew everything about it. There are actually studies that show that the best programmers are 10 times better than the average ones. In terms of coding time, your debugging time, how efficient are you in developing software, and the speed or the efficiency of your of the product that you produce. So when you apply for jobs, everyone knows that you probably learned software in university, but they want to see who is a good programmer. A good programmer that is the one that can finish tasks quickly. Okay. And you're probably going to say to yourself, okay, I'm not a good programmer. Well, neither was I at your age, but with practice we became. So the good thing is that this is not something that you are born with, but you can make yourself a good programmer by practicing more. And this applies to also it's like any other thing that you do in your life or you're passionate about, for example, in sports. The greatest athletes, they probably were born with some skill, but they worked on their skill through practice and honed on those talents in order to be one of the greats in the world. Okay, so now I'm going to talk about the design aspect of this course and where are you going to use it in outside of this course. So the first time that you're probably going to be asked about your design skills after leaving this class or after leaving university is when you're trying to apply for jobs. So when we try to hire people at Cerebras, for example, we basically get a large stack of resumes and transcripts, and we need to filter these out. The first thing we look at is obviously the transcript, and we look at the grades. Okay, if the candidate has good grades, that's good. That means they have the basic knowledge that probably need. Then we bring in the candidate to do interviews. And during the interview, we do not look for the grades anymore. We try to look for what the skills are in the project that we're going to do. Okay? So we look for whether for the ability of the candidate to design or solve problems that they haven't seen before in a timely manner. How they communicate, because that's a very important part of the job. You're going to communicate with your team, you're going to communicate with your manager or with the CEO, for example. And some of the questions that we usually ask are, what is your proudest design achievement? This question, while it might be simple, basically it tells us a lot about the candidate. It tells us what their knowledge about the project that they are talking about, what their contribution was, and it tells us also about their communication skills. Maybe they did a really good job, but they weren't able to communicate why is it that important, or why is it that good, why the outcome was that good. It tells us also how passionate the candidate was about the project they worked on. So this is definitely a candidate we want to hire because we know that they're going to do whatever it takes to basically get the project done. The other question that we usually ask is, describe a difficult debugging problem that you faced. And this is a really important question because, first of all, it shows the ability of the candidate to learn on their own. During the job, you're probably going to run into a lot of issues, and you won't find someone who will tell you, okay, this is how you do it. You'll probably have to do it on your own. So it tells us that the candidate is able to learn. It tells us that they have the passion to put some effort into what they are doing. What else? And it tells us that, okay, this person didn't just ask someone to get their grades, for example. Because if you just ask someone to tell you what to do, that means you gave up on the problem, and that's someone we don't want to hire, for example. Now, debugging is important because in every engineering design that you're going to work on, you'll definitely run into issues, and it's not going to work from the first time. I personally spent half of my time at Cerebras, for example, debugging issues that, because we've developed new things and we ran into issues that we haven't thought about before. In this course as well, you're going to, as I said before, you're going to run into bugs, a lot of bugs, and we're going to teach you some of the tools on how to overcome these issues. Okay, the second time where your design skills are important are when you're trying to build your career. Now, probably most of the courses at U of T teach you how to analyze the work that you are doing, and that's very important. But in your career, you're probably going to run into problems that you have to get creative in, and you have to design something that works for this particular issue. And obviously, with design, you will have to evaluate different choices and different aspects of the problem in order to find the best solution. But again, I can't emphasize it enough. To be creative is part of your any job that you're going to do. It requires the breadth, it requires knowledge of different things, and it requires you to measure the impact of this, the choice that you're going to make on different teams or on the company overall. Okay, and that comes also with communication, because you're probably going to come up with an approach to the problem, and you will have to present a proposal, for example, to your superiors, to your team members, in order to convince them that this is the right thing to do. So communication is a key part in this. You will also have, for example, maybe you're building your own company and you want people to invest in you. You will have to communicate to the external clients who don't know probably the details of what you are doing or the engineering issues that you're trying to work on. You have to convince them in some way or another why they should invest in you. Okay. The third thing where design is important is when trying to build or scale up your company. Some of you may have like a passion in entrepreneurship after graduation, and they're trying to start their own company. And design is very important in this aspect. I'll give you an example from Cerebras, for example. Cerebras started in 2016 as a small hardware company that is trying so hard to compete with NVIDIA, but we weren't able to, because at that time we were only able to support a handful of small models, small machine learning models. Okay, the biggest challenge for us to convince clients, to attract more clients, was how can we scale to bigger models while minimizing the cost of our product. Okay, and through software co-design and an iterative process, we actually revamped the whole software stack that we had at Cerebras. We started from scratch after like 2-3 years probably, and we are now able to basically train models of sizes greater than 1 trillion parameters. That's one of the largest models in the world. I think ChatGPT, the recent ChatGPT model, is around that size. And we do this on a single wafer scale engine that you're seeing here. So with doing this, we are basically now trying to getting more customers. More customers means more profit to the company, and that makes taking us to be a bigger company and not a startup anymore. Okay, so that's kind of the motivation of why these aspects are important and what we are trying to teach you. Now, let's dive into the details of this course. I'll give you a quick overview of what to expect in this course. Everything is in the syllabus, but I'll try to go over the important parts. Okay, let me see how we're doing on time. Yeah, we're good. Okay, so in this course, you're going to build something like Google Maps, a mapping project, where you're going to build a graphical user interface from scratch. We'll provide you with the tools that will help you do that. You will try to, for example, search for routes, like you would say that I want a route from point A to point B. You will go and try to find the shortest path that gets you to your destination and visualize it on the map. Okay? The project is divided into a set of milestones. The first 2 tasks in the course are individual. You're going to do them on your own. And they consist of milestone 0, which is a basic milestone to learn the tools that you're going to use in the course. And written document 0, which is based on the Made to Stick book. And I think Professor Chung is going to talk about it. The rest of the tasks are going to be done in a team of 3. And there are 4 milestones to complete this project, in addition to the written and documents and presentations. The evaluation. Around 50% of the course is going to be, you're going to be evaluated on your software design skills. The other 50% are going to be based on communication. But these things go hand in hand. You will definitely need your communication skills in order to properly be evaluated in your software, and vice versa. There are no midterms or exams in this course, so everything is done in the project. And you're going to be mentored by 2 people. One is the CI, who represents as a project manager, and they probably don't know much about the engineering details, but they will evaluate your communication skills. And the TA, who represents the engineering manager, and they will evaluate you on your software design. Okay. So labs start this week, actually today. There is a lab at 10 a.m. And for the first 2 weeks, you're going to go over milestone 0. Milestone 0 is a basic milestone. It's not that difficult to complete. It will teach you all the tools that we're going to use and where to find the quick start guides that we'll provide on Quarkus to learn these tools. These tools are very important, not just for this milestone, but for the rest of the course, because they will help you to learn about debugging, how to debug issues, and for example, revision control or Git, if you haven't heard of it before. We'll cover this in the next lecture anyway. Okay, so as I said, labs start this week. There are 4 lab rooms listed in the syllabus. You will work on the UG machines, and your login is your UTOR ID, and the initial password is your student number. But please change that as soon as like possible through this command. And in the first week, you're probably not going to find TAs in every lab room, but you can stay in the lab room and work on your milestone. But if you need help from a TA, try to go to any other of the rooms that are listed in the syllabus. You'll probably find someone to help you. Also, you can ask any questions on Piazza. But to complete this course, you'll probably need more time outside of the lab hours. So there are two things you can do. One is come off lab hours to any of the lab rooms and work on your project if it's empty. If not, then you can work remotely from your machine at home through what we call VNC. If you don't know what VNC is, there is a quick start guide on Quarkus that will tell you how to work with it. There is also something called a virtual machine, which is like a lightweight representation or a lightweight image of the operating system that is installed on the UG machine. You can install that on your own machine and work from it. I don't recommend using it because it's not well maintained, as there might be some new libraries installed in the UG machines that we haven't known about yet. So I recommend using the VNC or just working in the lab. Okay. Starting from the 3rd week, which is January 20, you will work for the rest of the semester in a team of 3. And so for the first 2 weeks, another task apart from milestone 0 is to form your team. And to be in the same team, you have to be in the same lab room and in the same lab time slot and the same tutorial time slot. So not necessarily in the same lab room, but As long as you both the tutorial and the lab time slots align, then you're okay to form the team. So choose, the team is going to stay with you until the end of the semester, so choose wisely. Try to find someone who has the same work ethic as you, who can communicate well, or you can get along with well, and who can complement the skills that you have. Sometimes some people are very good at software, but they need someone who's good at presentation, for example. So these kind of complementary skills go well together. Okay, so you can use Piazza to find team members, and once you've found the team or you've decided what team you're going to be in, just enter your team information on Quirkis. I'll send you instructions on how to do that. If by the third week you can't find a team, Professor Chong is going to help you find one. Okay, so apart from the labs, there are also tutorials. The tutorials are very important because they do cover aspects that we probably won't cover in the lectures. The first 2 weeks are especially as important because they cover the, they teach you more advanced C++ techniques like templates and the standard template library. The knowledge of STL library is very important to complete your project because it will teach you how to communicate with the API that we're going to provide you to complete your milestones. There are 6 other tutorials throughout the rest of the semester. They cover hands-on topics listed. If you're interested, they are listed in the syllabus. Things like how to make your code faster, how to debug issues in a timely manner, how to, for example, do things in parallel in order to make things faster at the end of the course. Sometimes the tutorials will coincide with your meeting with the CI, so if you aren't able to attend the tutorial, all the slides and the videos will be posted on the website. Okay. Academic integrity. Again, as I said, there are no midterms or exams in this course, so everything, all of your evaluation is based on your communication and the project. So this is why we do not tolerate any plagiarism. Never share your code with anyone outside your team members. You can make discussions with others to understand how a problem is solved, but never share your code with anyone. Do not even look at or incorporate code from an older ECE297 project. We have access to every single submission from every student for the past 10 years. So, and we don't have any discretion in this. So once our automated checkers flag something as being plagiarized, we have to file a report. And probably the whoever copied or gave their code to someone else will be penalized. So please try to not to do so. Okay? Well, there is a quote that says by Warren Buffett, it takes 20 years to build a very good reputation, but probably 5 minutes to ruin it. So, okay. Your CI and TAs are your mentors, so ask them for help anytime you want by sending them an email or through in the lab or tutorial time. You can ask as many questions as you want on Piazza if you need any help, but please do not post code. If you are facing a difficult issue and you're not able to solve it, you can post it on Piazza, but privately, so only the instructors will be able to see it. You can email me or Professor Chong for any to schedule any office hours if you want. Okay, feedback. We also appreciate your feedback and take any constructive criticism you have. If we aren't doing something really well, you can talk to us or through email, or if you are a bit shy, you can also follow this anonymous feedback link to tell us about anything you want. And we also keep track of whoever participated in the lectures and will reward them with bonus points, bonus marks, and with chocolate bars. So if you've answered that question that's really good, you'll get a chocolate bar. If you point 3 non-trivial mistakes, by non-trivial we mean like not a semicolon, it's like a really non-technical issue in the lecture, then the next lectures, everyone in the class will get a fun-sized chocolate bar. We can't afford a bigger chocolate bar for everyone. Okay, I'm pretty sure you know who this guy is. It's Elon Musk. He bought Twitter a couple of years back, and this is the first thing that he sent to his employees. He's basically saying that only the exceptional performance will pass as will constitute a passing grade. But that's not us. We are more chill than that. Again, we know that perfection is not possible, so don't strive to only focus on this course. Try to balance things with other courses. But you also have to put some effort in it. I like to follow this graph. This graph shows you the pressure, how much you learn versus the pressure you put on the course. So if you don't put much pressure in it, you'll probably get bored of the task that you're doing, and you're not gonna learn much. If you stretch it a little bit and try to put some effort to get something at least working and try to improve it, then you will maximize your learning experience in this course. But if you try to focus solely on this task and ignore other tasks, you will probably get burnt out and your learning reward will diminish. This is called actually the zone of delusion. You're probably deluded that you're learning, but you're probably not. Okay, so that's it on my side. I'll give it back to Professor Chong. If you have any questions after the lecture, please let me know.
I'm going to try to do this really quick.
Yes.
I know it is close to the end of class, but I will get this started. So what I want to do now is to follow up on the message I sent out on the 1st of January. Sorry for interrupting your break at that point, but I thought it might give you an opportunity to actually get started. I don't know if any of you actually did get started yet, but I want to talk a little bit about WDO and made to stick just to end this lecture, okay? So that's one of the talks that you can do WDO on. I'll talk about this in a sec. So in WD0, what we're asking you to do is to take what you've read in Made to Stick, and I know it's a lot to read by January 25th, 6 chapters, almost 200 pages, but it's not a textbook, okay? That's one thing I want to kind of emphasize, okay? But we want you to take 3 principles from that and apply it to one of 3 presentations, okay? And these presentations are 10 to 11 minutes long, and you can talk about how these principles were used, how they could be used to make these presentations better and stickier in general, okay? There are 3 talks. One is a talk on AI by Ilya Sutskever, okay? One is from the introduction of the M1 chip with Apple, and the most recent one is this 2024 keynote on responsible AI techniques given at Google I/O, okay? So that's in a map in a brief statement what WDO is about, okay? I'm going to talk a little bit about what Made to Stick is and why we're asking you to use this particular text, okay? Now, we had a lot of options, right? When we kind of thought about this course, we could definitely suggest a whole bunch of technical communication textbooks. There are so many of them. A lot of people are trying to sell them to us because they know you have a class of 200. But what we found was when students use these textbooks or bought these textbooks, they never looked at it again, right? It wasn't something that they would come back to over the course of their career. Now, what we think we have with Made to Stick is something that does a little bit, something a bit different than what those textbooks do, okay? And really, it's more of a kind of a popular book that takes social psychology and behavioral economics and explains how communication works and why certain techniques are or are not effective, why ideas are or are not sticky, okay? And basically, what's really important about these books is the examples that they use, right? The principles themselves are pretty simple, okay? And they're more like books like The Tipping Point or Predictably Irrational. They're kind of popular books. And our hope is essentially that you will use this book to really understand how and why these techniques are important, and that'll help you convince you to use these techniques in the future, okay? Now, it's going to be very tempting to oversimplify what they say and to read the summaries of the text, okay? As I said, you can get the text in a variety of different ways. You probably can find it in a way that you don't have to buy it. But basically, if I was going to simplify this book, so I could just have this acronym, SUCCESS, right? Simple, unexpected, concrete, credible, emotional, and stories. But what's important about the idea of simple is that the idea of simple in this book is not about short, compact, or easy. Simple is really about compact and core concepts, right? So as in a proverb and not a soundbite. So that difference is really, really important, okay? And really, ultimately, the descriptions of the principles that you may read in summaries are not going to be enough to really understand them, right? It's the example